Alright guys, so we've got section 11.5. We're doing common and natural logarithms. Here's your 5 objectives. I hope this lecture goes fine. I'm doing this for my house. I don't have all the fancy equipment that I've got at work. But here's your 5 objectives, and most of it is going to be on the calculator. Most of the work you do will be on the calculator, so make sure that you have one with you before you start. You can go ahead and pause and go get that calculator. Alright, let's go and get started. So first objective, we're going to use logarithms or evaluate them using the calculator. So here is our first one. I've got log 41,600. Remember that if you do have log without a base, then you're really working with log base 10. So on your calculator there is a log button, but the point I want to make here is that even though there's no number there for log, it's still going to be a base 10. I'm going to go ahead and grab the calculator, and here is your log button. So I'm just going to click log. It's already a base 10. I don't have to worry about that. I can put in my 41,600. And if you want to close it, you can. You don't have to really. And then push enter. And we've evaluated a log base 10 of 41,600. So there's the first problem. You need to go back and look at that again. You can. Let's take a look at the next problem we have to do here again. It's another base 10. This time we're doing log 43.5. So again, I can go log and just enter 43.5 in there. I'm not going to close it this time, but there's your evaluation. It's 1.63. And if you need to look at that again, what buttons I clicked, I went log, and of course 43.5. Not a very difficult thing to do there. All right, next problem. Again, try it. You can pause this, and then you can check, see if you did it right with what I do. So we've got log of base 10, 0.442. So log, let's go over here. Let's go log 0.442. I'm going to close this time just because. And there's your evaluation. So there's a value. These are exactly what you punch into Math Excel, or sorry, my math lab. Do remember though that you do want to round to 4 decimal places. You're going to want 4 decimal places, and then you're good to go. Okay. So use common logs in applications. So here's our first problem. They're giving us a pH formula here for water. So it says find the pH of water with hydration ion concentration that is 1.2 times 10 to the negative third if it's taken from a wetland. So our formula here, I forgot, I think I moved it here. So let's grab this real quick. Where's my cutting tool? Let me take a picture of this. Let's cut this off. Let's cut it. Let's come back to our problem. Let's place it here. All right, so here we know that we've got, they want us to find the pH concentration or the hydronium ion concentration of 1.2 times 10. That's what's going to go inside of our hydronium parentheses here. So we're just going to do negative log of 1.2 times 10 to the negative third. I'm going to go ahead and punch that into my calculator. That'll produce for me the pH that I need. So I've got, I'm going to clear this up. Let's minimize this. Negative, don't use the minus. We've got negative log, parenthesis. Oops, I've got an extra one in there. And that was 1.2 times 10 to the negative third. 1.2 times 10 to the what was it, negative third? Negative third. So again, negative 3. Push forward so that I get to the big parenthesis there, and I can just press enter, and there's the calculation there. So I've got approximately 2.9208 on that one. So again, all this you can just do in your calculator. Here's the next one. So again, it wants to find the hydronium this time. So this time we're going to find the hydronium ion concentration of a solution that has a pH of 4.6. So we know that the pH here is 4.6. So for pH, I'm going to replace that with 4.6. That is equal to log of the hydronium here. To do this one, I'm going to want to go back into the power form. So I know that the base is 10 in this case, so I'm going to do 10 to the 4.6 is equal to negative hydronium here, hydronium cubed. Okay, so let's do that first. In our calculator, we've got 10. There we go. Here we go. 10 to the 4.6. There's that. And then, of course, I can just make that into the negative number if I needed to. All right. Moving on, moving on. All right, so loudness, decibels. The loudness of sound is measured in a unit called decibels, and we abbreviated dB. To measure it with this unit, we first assign an intensity of I naught. I to the 0 power is pronounced I naught to a very faint sound called the threshold sound. So I naught is the threshold of our hearing. So a particular sound has intensity I, then the decibel level of this louder sound is, and then they've given us a formula for that sound. It's 10 times the log of I over I naught. Just to give you some ideas of what threshold sounds like, here's a couple of examples for you. 60 decibels is our normal conversation. Got rush hour at 90 decibels. Garbage truck is about 100. If you go to a rock concert, you got about 120. That's also thunderclap. Gunshots, you got 140. Some of your guys' headphones are actually pretty high as well. That listening to you guys' headphones at such a high level, you're going to end up going deaf at some point too. I don't remember exactly where, but I think you guys were maybe rock concert status. And if I can hear it, then you're probably much louder than that. All right, let's see here how we use this guy. So find the decibel level to the nearest whole number of a whisper with intensity with the I of 115 times I naught. So in this case, we're just going to plug in the number that they've given us. There's not much other information here, so let's see here. We're going to go 10 times the log of, let's see, I naught is here, and they told us that I is 115 I naught. I'll just make that I naught. Okay, nice enough. I naught over I naught is going to be a 0, so we're really just going to do 10 times the log of 115 for this problem. So 10 log 115, and there we go. We got nearest whole number. I'd go with 21 on this. So this is actually, I'll go approximately 21 because it's not equal to, I did round it off. All right, evaluate a natural logarithm using a calculator. All right, just like logarithms, there's another special type of logarithm. It's called a natural logarithm. And when we talk about it later on, probably it'll be in the next section. When we talk about natural logarithm, we're talking about this number e. But we don't like to say log base e. Instead, we'll just say ln. And I don't know why it's ln. Natural logarithm kind of sounds like it should be NL, but it's not. But I'll show you where that's in your calculator. So here's log. Right under that, you'll see ln. That's your natural logarithm button. So as we work with those, that's the button you're going to want to use right over here, ln. All right, let's take a look at some of these problems here. So just like before, we're just going to plug them in. We want to find ln 0.01. So we're going to go ln 0.01, and then just press enter. And there's our value. Next problem says find ln 27. Okay, so we're going to go ln 27, and there we go. Okay, you can try this one on your own. You can pause the video, try it, and then double check with what I've done and see if you did it the right way. So we've got ln 529. Come back, we've got ln 529, press enter, and 6.2709, or 6.2710, because you can round to the fourth decimal place here. That's what we typically do when we're talking about logarithms. So using that one in applications as well. Again, let's see here. The altitude in meters that corresponds to an atmospheric pressure of x millibars is given by the logarithmic function defined by f of x is equal to 51,600 minus 7,457 ln x. And they want us to approximate the altitude at 700 millibars of pressure. So 700 millibars is an x value because they told us it was x millibars. So all we really need to do is plug into our formula here, 7457 ln of 700 millibars. And of course this would be f of 700. So I can throw that right into my calculator just the way it is. I've got, let me figure this up, 5, 1, 1, 2, 3, and then we're taking away 7,457. 7,457 ln of 700. So 700 parentheses, and there's our answer right there. All right. I feel like I want to say any questions, but I know you're not going to be able to ask me them. But I still got that habit. All right. So base change formula. I talked to some people about the base change formula already. It's a pretty simple formula. I really like it a lot. It really lets you work with logarithms if you don't have one of these graphing calculators at home that lets you do that. And here's what the base change formula is pretty much saying. They're just worried about make sure that a is bigger than 1 and b cannot be 1. Or sorry, a has to be bigger than 0, b has to be bigger than 0, and they both cannot be 1 either because, and then we talked about it, that would just give you a constant, which would make it just a line that we really don't want. But here's what the formula is saying. It's saying log base a of x can be rewritten as log new base of whatever you want it to be. B can be whatever. So for example, let's say I had, if I had log 4 of 4, 5, I don't know, whatever. This is just an example. I can rewrite this as log of 5, and again, I kind of split it like this, kind of like if it was a fraction, just kind of a little thing that reminds me. So I've got log of 10, 5 in this case, log base 10 of 4 in this case. So I've gone from having a log base 4 to everything being in the log base 10. And again, I don't have to have that be a 10. At this point, if I wanted it to be 3 or 2 or 1 or whatever I wanted to, I could do that. But usually we like to just leave it at the base 10 because most calculators do have a log button. Even in your iPhones or your Androids, they'll have a log base button. They usually don't have that log base like we have in our graphing calculator. So it's kind of nice to know this base change formula because it helps out sometimes. Sometimes you can do one part of it versus the other part, but it's just a very simple formula there. So let's take a look at this example here. They say find log base 3 of 17. I'm going to show you both ways just so you can see that it really is going to be the same thing. So we've got, if you don't remember where that's at, you're going to go math, log base, right here. And I don't remember already. So it was base 3 of 17. So base 3 of 17. And the value is 2.5789. Now I'm going to show you using the base change formula. So I'm going to do parentheses. I'm going to do the log of 17. Close that and then close the numerator. And that's going to get divided by the denominator, which is going to be log base 3. Close, close. So I'm saying those two are equivalent, and we should get 2.5789. So really nice formula to have. Kind of gets you out of some tight spots sometimes, or even allows you to kind of get rid of one of the logarithms if necessary. So log base change formula. In this case, one more time, that is simply equal to log of 17 divided by log of 3. In this case, they're both base 10. For whatever reason you wanted it to be a different base, you can do it at that point as well. Alright, so let's take a look at this. Use natural logarithms in the base change formula, and then the function f of x is equal to 38.83 plus 4.208 log base 2 of x to find the percent of women who return to work after having a baby in 1990. So again, just very simple here. I've got f of x is equal to 38.83 plus 4.208. And in this case, I would be multiplying by log of x, or sorry, log base 10 of x, and that's going to be over log base 10 of 2. So then you can just throw in your equivalent for 1990 or 1990 itself. But that's really what the base change formula is really asking you to do. Once you do have that number plugged in, then all you have to do again is throw it in your calculator one more time, and then you'll be good to go. That is 11.5. I really wish I could answer some questions for you guys. Talk to each other, talk to your neighbors, try to figure it out on some stuff. If you're really struggling, send me an email. I'll try to reply to that. I will be kind of busy, but I'm definitely going to try to do that for you guys. I'll try to get the other video up again as well tomorrow. So I'll be looking around my email, see if there are questions from you guys. Guys, have a great week, and I'll see you guys. Well, I won't see you tomorrow, but I'll have the next video up tomorrow. All right, guys. Bye.